Hello student, good morning. Today I am going to discuss from the last class. Today I am going to discuss about the atom. We have used so many times the term atom and molecules. Then now I want to tell about the atom. John Dalton in 1809 regarded the atom as a hard, dense, and smallest indivisible particle of matter. Indivisible particle means further it can't be divided. If matter is big, if you will break into pieces, so many pieces, then finally you will find very small, smallest particle which further you can't divide. That is called indivisible particle. Then according to John Dalton, atom is a indivisible particle of matter. However, the emission of negatively and positively charged particles from radioactive elements as well as from gases on the passage of electricity at very low pressure convinced the scientist that atom is not indivisible, means it can be divided further, or you can tell that atom consists of smaller fundamental particles. It is now fully established that atom consists of three major fundamental particles called electron, proton, and neutrons. Electron is a negatively charged particle having a charge equal to 1.60206 into 10 to the power minus 19 coulomb and a mass equal to 9.1091 into 10 power minus 31 kg, very less. Since the charge on the electron is the smallest charge of electricity, it is usual to speak of the charge on an electron as unit negatively charged. The mass of electron is in AMU, atomic mass unit, it is 0.000547. In AMU, its mass is 0.000547 AMU. Now come to the proton. Proton is a positively charged particle with charge equal and opposite to that of electron and mass equal to 1.6727 into 10 to the power minus 27 kg, little more than electron, means proton is heavier than electron. Thus, proton carries a unit positive charge. Electron carries a negative charge, one negative charge, but proton carries a unit positive charge and has a mass equal to 1.00728 AMU. Again I am repeating that its mass, proton has mass equal to 1.00728 AMU. Okay. It is heavier than electron. Now neutron. Neutron is a neutral particle having mass equal to 1.6748 into 10 to the power minus 27 kg. And this is neutral, no charge, no negative, no positive. Neutron is neutral. Thus, neutron carries no charge and has a mass equal to 1.00866 AMU. I have told mass in 2 units, in kg as well as in AMU, that is atomic mass unit. Since atom is electrically neutral, it contains an equal number of electrons and protons. In an atom, number of electrons and number of protons are equal, and this is actually called atomic number of that atom. Atomic number of that atom means atomic number of an atom that is equal to number of electron or number of proton found in an atom. Now I am going to discuss other term like this properties of matter and their measurement. Every substance has unique or characteristic properties. These properties can be classified into 2 categories: physical properties and chemical properties. What is physical properties? Physical properties are those properties which can be measured or observed without changing the identity or composition of the substance. Some examples of physical properties are color, odor, melting point, boiling point, density, etc. The measurement or observation of chemical properties require a chemical change to occur. The example of chemical properties are characteristic reactions of different substances. Characteristics reaction of different substances. These include acidity or basicity, or you can tell combustion or combustibility, etc. Many properties of matter such as length, area, volume, etc. are quantitative in nature. These are quantitative in nature. Any quantitative observation or measurement is represented by a number followed by units in which it is measured. For example, length of a room can be represented as 6 meter. Here 6 is the number and m, small m, denotes meter, the unit in which the length is measured, that is the here meter. Now I want to discuss about the International System of Units, SI system. There are actually 2 systems in commonly. CGS system, CGS, C means centimeter, G means gram, S means second. CGS system, it is a common. But SI system at a universal level SI system, international system. SI means international, I means international, S means system, that is used, and that is called International System of Units, SI system. And another common system, that is the CGS system. C means centimeter, G means gram, S means second. Then now I am going to discuss about the SI system. The SI system has 7 base units. These units pertain to the 7 fundamental scientific quantities. The other physical quantities such as speed, volume, density, etc. can be derived from these quantities. Now see, seven you can say fundamental these things are base physical quantities 7. Seven this is there, quantities are there, base physical quantities 7 are there, that I am going to tell what is their unit and how it is represented. This is very, very important. 7 are there. What are the 7? Then length. First is the length, second is the mass, third time, fourth electric current, fifth thermodynamic temperature, sixth amount of substance, and seventh luminous intensity. Generally these 7 you can say base physical quantities you require to tell about the any substance. Any substance is there, then you want to know what is its length, how much it is mass, how, and you want to tell or want to know time, electric current, thermodynamic temperature, how much it is there means number, amount of substance, amount means quantity, that you want to know, and if it is a light, then luminous intensity, length, that is a symbol for quantity of length is L, a small l, mass is a small m, time is a small t, electric current is I, thermodynamic temperature is T, capital T, amount of substance is a small n, number, small n means number, that is also can tell amount of substance, and luminous intensity, that is the IP, I a small p down. This is the symbol for quantity. Now name of unit. How will you measure the length in SI system? Then it is measured in meter, a small m, meter. Symbol for SI unit is meter, a small m. Mass, kilogram, kg, and time, second, a small s. Electric current, ampere, electric current you can measure in ampere, A, its symbol is A, and thermodynamic temperature, that is a T, what you are denoting by T, that is its a unit is Kelvin, K. Amount of substance, N, actually so many atoms, molecules, ion, this exists in a very large number. That's why it is represented by a bigger unit, that is called mole, M-O-L-E, mole. But its symbol is MOL, mole. Its unit is mole, M-O-L-E. But symbol for SI unit for mole is MOL, mole. And for luminous intensity, last you can say quantities, luminous intensities, it is unit is candela, CD. It is symbol is CD. Then this seven base physical quantities I have told you. Okay, these are just used. If you want to tell about the time, then time in second. If you want to tell length in meter. Like that way, all are these units are used for the substance, any substance. Now I want to tell you some these things, prefixes used in the SI system. You should know. You might be knowing also, but some you might be not knowing. Okay. Then what are that things? Some important prefixes used in the SI system I am telling. 10 to the power minus 24. This is a very small. 10 to the power minus 24. This is a very small, and its prefix that is we are telling it as calling as a yocto. YOCTO, yocto. YOCTO, yocto. 10 to the power minus 21. Jepto, ZEPTO, jepto. 10 to the power minus 18. Atto, ATTO, atto. 10 to the power minus 16. Femto, APMTO, femto. 10 to the power minus 12. Pico, PICO, pico. 10 to the power minus 9. Nano material, what you are telling, that nano. 10 to the power minus 9. 10 to the power minus 6, this is a common. Macro, MICRO, macro. You should not confuse with macro, that is a MACRO, macro, that is the big unit. But here micro, AMICRO, macro, that is a 10 to the power minus 6. 10 to the power minus 3 is 10 to the power minus 3, that is the milli, MILLI, milli. And 10 to the power minus 2, that is called centi, that is common. 10 to the power minus 1 is called deci. 10 you know that only 10 is deca. Like that, when in positive way, positive sense, 10 to the power 2, 10 to the power 2 hecto, 10 to the power 3 kilo, 10 to the power 6 mega, 10 to the power 9 giga, 10 to the power 12 tetra, 10 to the power 15 peta, 10 to the power 18 exa, 10 to the power 21 zeta, 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 and 10 to the power 24 iota, YOTA, iota. This I have told about the prefixes. It is used in solving the numericals. Okay. Now I am going to tell about the some terms which you should know. As for example, mass and weight, volume, density, temperature. Okay. Now you should know more about the, you might be knowing little thing, but now you know somewhat more. Mass and weight. Mass of a substance is the amount of matter present in it, while weight is the force exerted by gravity on an object. The mass of a substance is constant, whereas the weight may vary from one place to another due to change in gravity. Now, you should again you should know, the mass of a substance can be determined very accurately in the laboratory by using an analytical balance. The SI unit of mass already we have discussed that it is a kilogram. However, its fraction gram, that is a 1 kg is equal to 1000 gram, is used in laboratory due to the smaller amount of chemicals used in chemical reaction. See, 1 kg means 1000 gram, but sometimes you require very less quantity, as for example 10 gram, 5 gram. Sometimes you want to take weight 250 milligram, then 1 gram is equal to 1000 milligram. Hence, in a balance, analytical balance, there you will find weight in milligram also, gram also. Generally, kg is a big amount, but in lab we require less quantity, to weigh less quantity. Weighing machine, weighing balance, that is from that you can measure up to 0.01 milligram, so less. Now just you we can come to this volume. Volume is volume has the unit of length power 3, cubic power 3, length power 3. So in SI system, volume has units of cubic meter in SI system, small m power 3 cubic meter. But again, in a common unit, it is also written as a liter, capital L, liter. A common unit is liter. Generally, liter is used for liquid or for gas. Liter L, capital L, which is not an SI unit, this is not SI unit, is used for measurement of volume of liquids or gases. 1 liter, already told you, 1 liter is equal to 1000 ml, milliliter. And 1000, another relation, 1000 centimeter cube means centimeter into centimeter into centimeter, length, breadth, height. Centimeter cube, that is called 1 decimeter cube, dm power 3, decimeter power 3 cube means, I told you one major relation, 1 liter is equal to 1000 milliliter. And second relation is 1000 centimeter cube, that is called 1 decimeter cube. Both are equal. In the laboratory, how will you measure volume? That I am telling in a lab. If you go to the lab, how will you measure volume? Then in the laboratory, volume of liquid or solution can be measured by graduated cylinder. First thing. Second thing, burette. Third thing, pipette. This is called glassware. And also volumetric flask is used to prepare a known volume of a solution. Volumetric flask is also used to prepare a known volume of a solution. These measuring devices are you will find in laboratory. Okay. Now I am coming towards the density. Density, how will you define the density? The density of a substance is the amount of mass per unit volume. Per unit volume means mass of 1 unit volume, means per cubic centimeter or per cubic meter how much its weight is there. Means if length is 1 centimeter, breadth is 1 centimeter, height is 1 centimeter, what is its mass? That is called density. Or in SI system, 1 meter length, 1 meter height, 1 meter breadth. For this, how much mass is there? That is called density. Means SI unit of density is equal to SI unit of mass divided by SI unit of volume. Means kg divided by cubic meter. Or you can tell kg m power minus 3 kg per cubic meter. The unit is quite large and a chemical often expressed density in gram cubic centimeter, gram per cubic centimeter or per ml. Actually, this unit kg per cubic meter is a big unit. Hence, for a smaller unit, we used gram centimeter minus 3, means gram per cubic centimeter or gram per milliliter. This I told about the density. Now, temperature. Temperature actually has some relation that you should know. Degrees Celsius and Fahrenheit, Kelvin, these are the important. Actually, temperature is measured in Fahrenheit also. Fever you are measuring generally in, you can say this in Fahrenheit. Sometimes in degrees Celsius you are measuring the temperature. And in SI system it is Kelvin. Then how all these temperatures are related to each other, that I am going to tell. Temperature on, you can say, two scales are related to each other. How? Then degree Fahrenheit, F, capital F, degree Fahrenheit is equal to 9 by 5 degrees Celsius plus 32. F is equal to 9 by 5 degrees Celsius plus 32. This is a very, very important relation. And other, Kelvin. The Kelvin scale is related to Celsius scale, degree centigrade, what we are telling, as K is equal to degree centigrade plus 273.15. 273.15. This is the relation between K and C. K is equal to degree Celsius plus 273.15. Okay. How this 273 term came, 273.15, just I want to give you little idea. Actually, all of you know that if we will decrease the temperature, then volume of the substance will contract, volume will decrease. Or if we will heat, then volume increases. Here I want to tell you that if we will decrease the temperature, then volume decreases. Then if we will decrease, if you will decrease the temperature slowly and slowly, then its volume should decrease. Then after decreasing the temperature, volume will be less. Then you will reach a temperature. At that temperature, volume should be 0. Then that temperature, that is called minus 273.15. At this low temperature, volume of the gas becomes 0. That is called absolute temperature. Absolute minus 273.15. That you convert it in a positive, then it becomes 273.15 Kelvin. Kelvin, correct? Then how you can say minus 273.15 that is required to bring the volume of the gas. 1 ml, suppose you have taken a gas, now it became 0. Actually, this is the hypothetical. By the graph, this value has come. Till date, it has not been seen. Up to minus 240, in case of helium gas, it is observed. Okay. Today, I am stopping only here, and again I will meet you next class, and if possible, numericals I will give I will solve the numericals. Some numericals I will solve on a sheet and will give you, most probably wherever it is required. I will do like that, so that you can know the numericals also, and numericals will be up from basic level to IIT, medical and higher level also. Okay, generally I will give for IIT and medical level, but it will start from the easy to toughest level. Okay, thank you.